much as you can. I'm starting the recording. So today I thought I would just go through one of the topics that actually comes both in paper 1 and paper 2, and also carries about 5 to 8 marks of your examination. And most students don't like it, but it's actually very simple once you just know all the properties summarized in just one form. So that's called circle properties. So we'll first of all start by looking at the circle itself. It's just a, it's flat. It's a two-dimensional geometric figure. So it's just a flat circle. So I'm going to start off with talking about certain angles in a circle. We're going to talk about cyclic quadrilaterals. So we're going to go from angles in a circle, then uh, properties of the angles inside the circle, then we go to cyclic quadrilaterals, and we're going to look at tangents at the end. So for you to understand this topic practically, you have to know all the given definitions. You know, when someone says, what's a chord, what's a tangent, what's diameter, what's a segment, you have to be able to know all these definitions. So the first thing that you have to know is what is circumference. So circumference is also known as the perimeter of the given circle. So if I were to go around this circle, starting at a point and ending at the same point, that would be the circumference. If you look at your mensuration, you discover that, okay, circumference is 2 pi r. So that's the formula for circumference. But for this topic, you don't have to know this formula. You just have to know the basic definition of circumference. So circumference is just the total distance around any given circle. So if I were to draw a line here, that connects any 2 points on the circumference and passes right straight in the center of the circle, so at midpoint, so it's cutting the circle into two distinct halves. This line here is going to be called the diameter. So that line will be called the diameter. So diameter is a line that joins 2 points on the circumference. So let's say that's point A and point B. Both point A and point B have been joined on the circumference by this line here, and it passes through the center. So let's say that's center O. So that's diameter. However, in contrast to diameter, there is also another line called radius. So you have to be very careful with radius, because in terms of circle properties, it tends to form isosceles triangles at times, and you can use those isosceles triangles to sort of find angles uh, inside the circle. So any line that connects the center of the circle to any point on circumference is called radius. So this line right here will be called the radius. So it's any line actually that goes from center to circumference is called radius. Meaning even this line here, it's going from center all the way to circumference there. This line here, OA, from center to circumference is also called the radius. This line here also from center to circumference is also called radius. This line center to circumference is also called radius. So radius is just a line that goes from the center and joins any point on the circumference. So you have to pay particular note on that, and you're going to hopefully see with some of the practice questions that we're going to do. So you also have to understand something known as an arc. So an arc is just any part on circumference. So if I were to say, so let's label this point D. If I were to say the distance from A to D, that's a part of circumference. So being that it's a distance from A to D, it would be called an arc. Also, the distance from D to B is a small fraction on the circumference, so it will also be called an arc. Same here, the distance from uh, B all the way to A, that's also an arc. So an arc is just anything that's a small segment of the circumference. So it could be from there to there, from there to there. So as long as it's just part of the circumference, that distance is going to be called uh, is going to be called an arc. So in contrast to radius and diameter, diameter and radius, they are all passing through the center of the circle. Radius goes from center to any point on the circumference. Diameter goes from external point to external point, and it passes through the center. But what if we draw a line that connects any 2 points on the circumference, but it does not pass through the center? What are we going to call that? That line is going to be called a chord. That line is going to be called a chord. So if I draw a line that's connecting any 2 points on the circumference and it does not pass through the center, that line there is going to be called a chord. So this line here that I've drawn, it's not passing through the center, but it's connecting these 2 points there, let's say X and point Y. So this line that connects any other point on the circumference and it does not pass through the center is called a chord. And this region here, bounded by an arc, so you have got an arc there, the distance from there to there. So the region bounded by an arc and a chord is known as a segment. So this right there becomes a segment. And you've seen this here is radii, r, and the distance from there to there is radii, there, and this is an arc. So the region bounded by two radii, radii 1, another radii 2, and an arc will be called a sector. A sector has its own formula also. I think it's theta over 260 times pi r squared. So this region here is a sector. A region bounded by two radii, radii 1, radii 2, and an arc is known as a sector. A region bounded by a chord and an arc is known as a segment. So this becomes very important because just in a few pages, we're going to be talking about things like angle at center is twice angle on circumference, sustained by the same arc. You are going to see what that means in a little bit. So all these definitions are actually very important. So when I send you this video, you have to know all these definitions. They are very, very important. So let's now start on with our circle properties. And we're going to start off with an interesting one. We're going to talk about properties of a chord, because this one usually comes in paper 1, sometimes even in paper 2, where they draw a chord and they sort of they draw a chord and they put just a little bit of information in there. So the first rule, if I draw a chord there, a chord, remember, is a line that connects any points on the circumference and it does not pass through the center. So let's draw one chord there. So the first circle property of a chord is that if you draw a line from the center perpendicular to the chord, it actually bisects the chord. So a line drawn from the center of the circle perpendicular to the chord bisects the chord. That is, we are cutting this chord in two equal halves. So let's say this is my center. So that's the center of the circle. Or if I draw a line, from the center of this circle perpendicular to the chord, it's going to bisect this chord in two equal halves, meaning the distance from there to there. So this is called xy because it's a line passing through the center. Sorry, it's a line that's connecting any 2 points on the circumference, and it's not necessarily passing through the center. So if I draw a line from the center of the circle perpendicular to the chord, it bisects the chord. And remember, every time someone says perpendicular, it means we are meeting, the two lines meet at a 90-degree angle. So the distance from there to there is the same distance as there to there. And I want you to notice one thing, because this line here perpendicular to this chord has bisected the chord. If we draw a line from the center, if we draw a line from the center, like so, to the circumference, that's radii. If we draw another line from the center, going there, that's another radii, meaning the distance from there to there is the same distance as there to there, meaning this triangle here, triangle OXY, will become an isosceles triangle, meaning this side is equal to this side. It becomes an isosceles triangle. So you have to make sure you know all these points. So forming an so that's the first property that I want you to know, properties of chords. A line, so first of all, you have to understand what a chord is. A chord is this line here, line XY, because it's joining 2 points on the circumference and it's not passing through the center. And if you draw a line down the chord from the center, it meets the chord at a perpendicular angle there. This line bisects the chord, and it's usually going to form an isosceles triangle. So the other property of chords that we're going to talk about is that two equal chords equidistant from the center are equal in length. Two equal chords equidistant from the center are equal in length. So what do we mean by that? So let's say this is our center there, and from there I measure a distance of 5 centimeters or 6 centimeters or whatever. So let's say we measure 5 centimeters like so. So please, circle properties isn't hard. The only challenging part about this topic is just knowing all the properties of the circle, and just you just start to play around with the rules. It becomes very easy. So I measure 5 centimeters, then I go from there again and measure 5 centimeters from the center, 5 centimeters. And if I decide to draw a chord from there to there, the same distance, 5 centimeters, and also from there to there, same distance, 5 centimeters, and let's say this chord is AB and this chord is XY. So the length of from A to B will be the same length as X to Y, because two chords that are equidistant, when we say equidistant, this is actually a term from construction, which is another easy topic that I think we should do. So this chord here from the center, 5 centimeters, center to the 5 centimeters, that's what's called equidistant. So two equal chords that are equidistant in length from the center, two equal chords equidistant from the center of the circle are equal in length. And much more, these two chords are going to subtend equal angles at the center. So if we decide to make angles, so from there we go from that point passing through the center to that point there, and we draw another line from that point passing through the center to that point there, these angles there are going to be equal. So two equal chords that are equal in length, they subtend equal angles at the center. So those are the circle properties of chords that I want you to know. The first one is that the definition of a chord. A chord is just a line that joins 2 points on the circumference and it doesn't pass through the center. And if you draw a line from the center of a circle perpendicular to the chord, it bisects that chord and you're going to form an isosceles triangle. Chords that are equidistant from the center of the circle are equal in length, and those two chords are going to subtend equal angles at the center. So this is what I want you to know in terms of chords. So let's move on. Okay, here there is a question. Let me just draw it here so that you can see it clearly. I used faint ink because I was trying to draw these circles properly. I didn't think, anyway, we have got this graphics pad. I didn't think the notes will come out this faint on the digital platform. But we can draw as many circles as we can. So let's just say there's a line here. Draw a line. Okay. Okay, so the diagram looks like this. And this point here is the center O, and this is 8 centimeters, and this point here is 5 centimeters, and that's a 90-degree angle. And the chord has been named AB. So find the length of the chord, which is 5 centimeters from the center of the circle and has radius 8 centimeters. So you have to remember that this line here, so the first thing that you remember is that rule. This line here from the center of the circle, perpendicular to the chord, bisects the chord, meaning the distance from A to the center, this distance there to there is the same distance as from the center. Let me even put the O there. From the center, so O to there. So the distance AO is the same distance as OB. So if I have enough information just on one part here to find the distance OB. I can find the distance OB, then I can multiply that by 2 because I'll know that the distance OB will be the same distance as AO. So the whole thing, I can either multiply by 2 or I can just add them together. So how do I find the distance OB? I'm going to use the Pythagoras theorem. The Pythagoras theorem. So that part here, if I extend this angle, this will become your hypotenuse, which is C. Then these are your two adjacent sides, which can be either A or B or vice versa, because you know the formula 1 plus 2 is the same as 2 plus 1. I think this is a commutative law of addition, something like that. 1 plus 2 is the same thing as 2 plus 1. So it doesn't matter which one you start with. You can either say this is B, this is A, or this is A, this is B. It doesn't matter which one comes first. You will still get the same answer. Therefore, you state your Pythagoras theorem. You say C squared is equivalent to A squared plus B squared. C squared being the hypotenuse. The hypotenuse, that's 8 centimeters. So where there is a C, we're going to put 8 centimeters, but we use brackets as usual because the formula has these squares. So 8 squared is equal to A is 5, so we'll say 5 squared plus B squared is what we want to find, that distance there. So we're going to say B squared. Then from there, we're going to evaluate. So we're going to say 8 multiplied by 8, that would be 64. This will be 25 plus b squared. That will cross over. We're going to get 64 minus 25 is equivalent to b squared. If we subtract that, we're going to get 39 is equivalent to done 64. Okay, okay. So that would be 39 is equivalent to b squared. To remove the b squared, we square root both sides. So b, the square root of 39. So the square root of 39, our distance will be 6.2. So meaning the distance from there to there, distance from there to there is 6.2, meaning it's the same distance as there to there, which is also 6.2. The question said find the entire length of the chords, meaning the distance from there to there. So we can just say 6.2 plus 6.2. 6.2 plus 6.2, we're going to get 12.4, would have multiplied by 2. Therefore, the distance of the chord is 12.4. Were we given units there, centimeters? 12.4 centimeters makes perfect sense. So the entire distance from A all the way to B is 12.4 centimeters. So just one circle property, a line from the center of the circle perpendicular to the chord bisects the chord. We've been able to solve this question. If someone didn't do circle properties, if someone didn't study circle properties, they'll be like, what is this topic? Is it Pythagoras theorem? Like, you'd be so confused. So this is how we solve this question here. So let's move on to angles in a circle. Is there a question on this one? Okay, I'll just breeze through. I've just received a lecture invite from the teaching methodology course I'm doing at 17. So let's talk about angles in a circle. And I want you to know this one because the examiners really like this one. For some reason, I don't know why, it doesn't miss in any exam. And it's actually rather simple, where we just say angle at center is twice angle on circumference subtended by the same arc. So if we draw a circle like that, if we draw a circle like so, just extend it a bit, and we say that's the center, and from the center we draw a line going to the center like so. Okay, I think what I'll do after explaining this angle property, I'll finish the video on Saturday and then I'm going to send it to your email. Okay, let's draw another line from there all the way to there. And then I want this one to be better. Extend it from there to there. And we extend it from there to circumference. So you have to meditate on this rule. Actually, all the rules. Oh, crap. This rubber has just ruined my circle. Okay. Take this to circumference. Okay. Bring this back here. Okay, this looks good. So let's first define what an arc is. An arc is any point on circumference. So let's say this is AC. So this is an arc. The distance from that point to that point will be called an arc. So this arc here has to form two angles. No wonder they say subtends two angles. So this arc here, so let's follow this arc from there to there. That's the center of the circle. And then from there to there, it's formed this angle here, which we call 2x. And from there, all the way to the center there, and from there, all the way to the center there, or all the way to a point in circumference there, that's another angle there. So this angle here at the center is twice angle on the circumference, subtended or formed by the same arc. So let's say if this angle here was 100 degrees, this angle here will be 50 degrees because this angle here, this angle at the center is twice angle on circumference. And trust me, this question always, always, always comes. Like you'll be told to use this rule, either this rule or a cyclic quadrilateral or tangents. I'm going to send the complete video, but I want you to meditate on this rule. I have to log into class. I'll complete this video on Sunday because on Saturday I have to go to the library and study laboratory management. So let me just end this video here and I'll send the video after class. And I want you, the take home message here for today is I want you to know what a circle is, what diameter is, what circumference is, what a chord is, what an arc is. And I want you to know those properties of the chord that we've talked about, that if you draw a line from the center perpendicular to the chord, it bisects the chord. And when I send this video, you should also revise the Pythagoras theorem, but I'm going to send you these notes right away before I log into class so that you actually start going through them. All right, I will see you tomorrow. on Monday, but I'm going to make the video on Sunday. I'll finish the video so that we can do statistics next week. I'll see you on Monday. Enjoy the weekend.